We are covering exponents and radicals, a critical topic within the math knowledge subtest of the AFOQT. The AFOQT tests these concepts directly, not usually in word problems, so you need to have automatic recall of the rules. Let's dive into how you'll be tested. You won't just see a simple problem like x squared times x cubed. Instead, you'll see multi-step simplifications designed to test multiple rules at once. For example, you might be asked to simplify the square root of x to the sixth power, all raised to the third power. The key is to convert the radical to a fractional exponent. The square root of x to the sixth is the same as x to the power of 6 over 2, which simplifies to x cubed. Then you apply the power to a power rule, which states you multiply the exponents. So x cubed raised to the third power becomes x to the ninth power. A major exam trap is confusing the rule for multiplying exponents with the power to a power rule. When you multiply x squared by x cubed, you add the exponents to get x to the fifth. When you raise x squared to the third power, you multiply the exponents to get x to the sixth. The AFOQT loves to mix in negative exponents to add another layer of complexity. Remember, a negative exponent means you take the reciprocal. It does not make the number itself negative. For instance, x to the negative second power is 1 over x squared. A common trick question might involve simplifying an expression like the quantity 2 times x all raised to the negative third power. You must apply the exponent to both the 2 and the x, resulting in 1 over the quantity 2 cubed times x cubed, which simplifies to 1 over 8 x cubed. Now let's talk radicals. The most important simplification technique is factoring out perfect squares. To simplify the square root of 50, you must recognize that 50 is the product of 25 and 2. Since 25 is a perfect square, you can take its square root, which is 5, and move it outside the radical. This leaves you with 5 times the square root of 2. A frequent and costly mistake test takers make is improperly distributing a radical over addition or subtraction. The square root of the quantity a squared plus b squared does not equal a plus b. You cannot distribute a radical across terms being added or subtracted. Finally, you must know how to rationalize a denominator. If you have a binomial in the denominator with a square root, like 2 plus the square root of 3, you multiply both the numerator and the denominator by its conjugate, which is 2 minus the square root of 3. This uses the difference of squares formula, a squared minus b squared, to eliminate the radical in the denominator. For a mental shortcut, remember this phrase for exponent rules, MADS-PM, which stands for M, multiply bases, add exponents, divide bases, subtract exponents, power to a power, multiply exponents. This simple mnemonic can save you critical seconds and prevent simple calculation errors under pressure. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.